Okay, this is an example of a question where we're given an initial concentration and we're having to find an equilibrium concentration. Lots of different ways to ask these. We looked at three within class. The two we focused on were perfect square, which were some um, examples in the homework of perfect square, and being able to square root the whole thing to get rid of both the squares from the equilibrium constant expression. Then we looked at a quadratic formula. We won't do a lot of those in this class. And then we've looked at the third option is when you have a small k, then oftentimes we can do the x is small approximation. And that's what we're going to be looking at in this problem. So first thing we always want to do with these is to write our equilibrium constant expression. In this case, it is k is equal to b, concentration of b cubed over the concentration of A. So that'll be good to know. We also want to write our ice table. So we have A, we have 3B, and we're starting with 0.700 of A and 0 of B. So we know it's going to go in the B direction to products because we don't have any B. So we're going to minus X, we're going to plus 3x, don't forget that 3, because it's a 1 to 3 molar ratio. So every x, this goes down, this goes up 3x. So over here we have 0.700 minus x, and over here we have 3x. Before we go on, let's make sure the x is small will work. Remember, so you put your initial concentration 0.700 over your k, 4.6 times 10 to the minus 6, and that number needs to be greater than 400. And what I get is 0.7 divided by 4.6 EE negative 6, I get 152,000. So that is greater than 400. So we can use x is small assumption. So now let's put them into our k. So we know k, so k is 4.6 times 10 to the minus 6. It's equal to 3x cubed over 0.700 minus x. Now we could solve as like this, get a quadratic formula and get really complex, or we can assume, like we just checked we could, that this x is small enough that it won't affect the 0.700 on the bottom. So we're just going to leave it as 0.7. So now I will multiply this up and over. So 4.6 e to the 6, negative 6 times 0.7 equals 3.22 times 10 to the negative 6. And that is equal to 27x cubed. Don't forget to cube not only the x, but the 3. So 3 cubed is 3 times 3 times 3. So I'm going to divide both sides by 27. So 3.22 to the negative 6 divided by 27 gives me 1.19 times 10 to the minus 7th equals x cubed. Now I'm going to take the cubed root on my calculator. That looks like I'm going to do 1.19 times 10 to the minus 7th, and I'm going to do a caret sign, and then I'm going to do parentheses 1 divided by 3. And I get x is equal to 0.00492. Now, it asks, what is the equilibrium concentration of B in this question? Now notice, it's not just x. We wrote it right here. This is initial, this is change, this is equilibrium. At equilibrium, B will be equal to 3 times x. So I need to multiply x by 3, and I get 3x is equal to 0.0148, 3 significant digits. And so I'm going to try that, 0.0148. There we go. Important things to remember for this problem, we have to put this cubed here because it's a 3. We also have to put the 3x here, which is important. You'll notice that answers here are done with quadratic formula, but we can do the x is small approximation with this problem and get the same correct answer. So don't forget the 3x. Don't forget in the answer that you need to have a 3x. So some things to remember as you're going through this problem.